All right, everyone. So in the last episode, we learned a little bit about sort of the basic structure of programming. But the key thing that I'm going to focus on in this video is based on variables. At least at first, is we learned there are two different data types. There is a text data type, or I guess a string data type. So we can say hello. Jonah. And we also learned number data type. So 5, 2, 3, 4, or that could also be equal to 2 over 3, or just simple number. Let's just set it at 5. Now I'm going to introduce a brand new data type. One called a Boolean. So let's just say, let's just call this Boolean equals true. And a Boolean can either be true or false. So we have Boolean t, which is equal to true, and Boolean f, which is equal to false. Excuse me. And so why is this useful? You might think, well, why can't we just have text equals true or text equals false? It's because in programming you often want to essentially run some sort of code if something is true, or do something else if it's false. You want to check conditions, because sometimes something might be true whether it be a certain state in a game you're making or something like that. And the way you sort of structure this in a program is with an if statement. Because before, when we had our sort of program here, it is sort of linear. You say, okay, so if we run this code, it prints 1, moves to the next one, prints 2, and then prints 3. There's no way around it. It's going to do things in a linear order. There's no way of skipping around until now, because we have if statements. So what we can do is right here we can say if true. Let me just put some space here. If true, and then there's an indentation here. Print this. And of course, which is essentially saying is that we want to check a condition. In this case, the condition is always going to be true, so we just continue along. Print 2. So if you run this, it's going to be the same. But let's set this to Boolean f, which essentially is just a variable. It'll evaluate to false. So it's going to go, okay, Boolean t is true, Boolean f is false, print 1. Okay, we have to check to see what Boolean f is, and we remember back, okay, it's false, so we're not going to print this. So if we run it, and then it's going to go 3, you're going to get 1 and 3. So that's just one example. It is a very basic idea, is that an if statement will basically check to see if something is true or not, and if it's true, it does the code under it. And of course, it can have more than one line, like prints hello, and then all this code will run. Let's change this to Boolean t so it actually does run. So we get 1, 2, hello, 3, and if we had this equal to false, it wouldn't run that code. It's ignored. Anyway, you can also, have before you had a number like this, but you could also have it be equal to like a piece of math, 5 plus 5, or 5 at 2, or something like that. And you can also do something similar with Booleans. Let's just delete all of this. You can say v equals 5. Let's put this in parentheses. 5 is greater than 2. So what v is going to be equal to? It's going to be equal to true or false, but it's going to be equal to true because 5 is greater than 2. So what we're really saying here is of course, v equals true, because it evaluates this in the parentheses. And of course, if we were to change this to less than, it would be false. Now, there's a lot of different ways you can, a lot of different comparisons you can do with numbers. You can do less than, let's change this to A. A equals B equals, maybe you want 5 greater than 2. C equals 5 is less than or equal to 2. Or if you want D equals 5 is greater than or equal to 2. And then finally, E is equal to 5 equals 2. Now, it's important to note that this is different than a single equals. A single equals is always assignment. You're assigning a value to a variable. And then 2 equal signs is a comparison. So all of these are going to be set to different things. For example, let's actually just illustrate what this is actually going to be. So A is going to be equal to false because, of course, 5 is not less than 2. But 5 is greater than 2. So we have B equals true. Next, we have C is false because 5 is not less than or equal to 2. And then we have D is true because 5 is greater than or equal to 2. And then finally, this is false because obviously 5 and 2 are not equal. E equals false. All right. Now, and also I want to illustrate again that you can put variables here instead of a number, as you do anywhere. Anywhere you have a value like this, you can also have a variable. All right. Now, let's run a program that determines if a certain number, okay, number is 5, is able to be held on your hands. Like, you can count on your hands. So what are the conditions for that? Now, here, we know that we have 10 fingers, so the number cannot be any greater. Number cannot be any greater than 10. And you can sort of hold 0 in your hand, but I wouldn't count that. I think you can only hold 1 to 10. So you can say number cannot be 0. And next, I would say that you can't hold negative numbers either. So number cannot be negative. Now, these are all conditions that number has to pass. So of course we're going to use an if statement to sort of figure this out. So we have to say if number, and essentially our goal is to print a message. This number can be held on your hands. So first, if our number has to be greater than 0. So if number greater than 0. Now, let's try this out. Of course, we met one condition. Put an X right here saying we did it. Sorry. Number cannot be 0 and number cannot be negative. We got those two done in one sort of condition here. Because obviously, if number has to be greater than 0, it cannot be negative, and also it cannot be 0. So, but how are we going to get this this third condition right here? Number cannot be greater than 10. Well, you're going to be doing this with something like with an AND. So if number is greater than 0, is greater than or equal to 0, and number is less than or equal to 10. So what we have here is sort of a basic comparison, but we have two different conditions that's met in this one if statement. So we first check if number is greater than 0. Okay, let's just do this with 5. Sort of work through this program in our head to see what it's going to do. Okay, if number is greater than 0. Okay, 5 is greater than 0. And we move on. So both of these have to be true. Both this and this must be true. Okay, then let's go to the next one. Okay, number is less than or equal to 10. All right, that works. So let's check. So we think as of now that this should be print. All right, it can be. Now let's try another number. Let's try 0. Okay, nothing prints out. But I guess maybe you know if you used this program before that, okay, we give it a number that, okay, if it prints a message, that means we're good. But if it doesn't print a message, we can't hold this number on our hands. So that's really confusing. So what we want to do is an else statement. Essentially what an else statement does is that it will only run if this is not true. So let's give it a number like 0. We already have that in there. So it's going to check, is number greater than 0? No. This is what it's going to do. It's what's called short circuiting, which essentially means that it'll check this first condition, and because that's false, it's not going to check the other one, because it doesn't matter. They both have to be true. So let's run this. We get the number cannot be held on your hands. All right, so that makes sense. We have a condition where we have to make 2 Boolean expressions true in order for our message to be printed, and then otherwise we print the number cannot be held on your hands. And now you might think that, well, why do we have to have this else here? You know, we can just do print. Let's actually grab this here and do that. Why can't we do that? Well, that's because, as you can sort of see, or let's just try it. Let's give a number we can obviously hold in your hands, 5. That's in one hand. Okay, so we get both messages, which sort of illustrates that we need to have this else here to sort of separate it, because maybe we have some other code below or something that it's different from this if statement. We need to include in this else so that it's only run when we have when this statement fails. Because before, when we had this and we give it something like 0, it works perfectly fine. But in order for it to work all the time, we need to have this. We can have it indented. Now, just in the middle of this lesson, a sort of homework assignment would be is to make a program that will tell you how many hands and maybe how many hands and feet you need to count a certain number, which is sort of interesting. And you can do it with the sort of tools they've outlined here. All right, next. So far we've been comparing numbers, but you can also compare strings. For example, let's say we have something like name. Okay, name is equal to, let's say, Jonah. And let's say we want to say name, if we want to check to see if name is equal to something else. And of course we already know what it's equal to, but just for the sake of this program, this example, I'm just going to assume that we don't know what it is. So let's see. If name equals Jonah, let's say if name equals Jonah, print you are the programming teacher. All right. So if name equals Jonah, print we are the program teacher. You are the programming teacher. So obviously, when you run this, it's going to say you are the programming teacher. But again, what do we do if we want to have a sort of fail-safe if the name isn't Jonah, which is very likely for it not to be? You can say else print I don't know who you are. So let's actually, sorry, I have to change that. Let's say name is like Joseph. We run. The program doesn't know who Joseph is. All right. But what if we want to give a special greeting if you're a programming student? Because the assumption here is that when there's a person, I'm going to either recognize them as being myself, or the computer is going to recognize them as being me, a programming student, or it's just not going to know who they are. So we do that with something called an elif. Or an else if, which that elif is short for else if. So we can do elif name equals Pete, and we can say print you are a programming student. So what this is going to do is if we give it doesn't matter what the name is, it's going to check, okay, if name is Jonah, print you are the programming teacher. I'm not the best programming teacher. And then if that fails, if the name isn't Jonah, it's going to check, okay, maybe the name is Pete. And if that's true, if name equals Pete, remember 2 equal signs for a condition, and only one would be assignment, as we have up here. And it would print you are the programming student if name equals Pete, but otherwise it doesn't know who you are. But let's say we have multiple programming students. Let's say we have Pete and Dan. You might think, okay, let's put another elif. You can have as many of these as you want. Elif name equals Dan. You can print again, you're a programming student. And if we put Pete in here, it says you're a programming student. If we put Dan in here, it says you are a programming student. But if we put Dave has not been showing up to class. The computer does not know who Dave is. It says, I don't know who you are. All right. But the problem here is that this is really redundant. Is that we have the same message over and over again. And really, there's no difference between Pete and Dan besides their names. The computer isn't going to give them a special message. You could, but for the sake of this example, they're the same. Now, what we might want to do is say message, what we did like in the last video, message equals you're a programming student, and we see if I can actually copy it. We paste it in there, and then we print message here and here, and that'll work. But still, you're still doing the print message. It's basically the same as what we had before. It's even a little more complex because we have a variable. So we're not going to do that. What we're going to do is we're going to get rid of Dan. But don't worry, Dan is going to come back to us momentarily. Because what we can do is we can say if name equals Pete, or, this is exactly like and, or if name equals Dan, say you're a programming student. So what this is doing is the computer is checking, okay, it's first checking, okay, is the name Jonah? Nope. Is the name Pete? Okay, is that true? Alright, then we just continue. But if the name is not Pete, it's also going to check, okay, it's not Pete, but maybe it's Dan. So we're going to check to see if it's Dan, and then if it is Dan, you print you're a programming student. This is exactly what I mentioned before, short-circuiting. It's going to check this first Boolean expression, and if it's true, it's going to ignore the other one, which is really important. Because later on, you're going to be doing like comparisons with numbers and that kind of thing, and you're going to realize, oh, why isn't my program working? It's because short-circuiting. It's not checking the other one. All right. So let's try this out. Say Jonah. You're a programming teacher. Next, let's try Pete. You are a programming student. All right. Let's try Dan. You are a programming student. And then finally, Dave. Computer doesn't know who Dave is. Now, and I'm not sure if I already showed this, but you can have multiple lines here, like print, you're a programming student, hello, welcome to class. And if we put Pete here, again, or Dan, it's going to say, you're a programming student. Hello, welcome to class. So you can have multiple lines here. And you can even have if statements inside of if statements, which is what's called a nested if statement. All right. So we have this nice little program here. And before you continue, I just want to point out that when you have this or, you always want to make sure you have an actual Boolean expression. You may be tempted to do that, because in English you will say, okay, if name equals Pete or Dan, that makes sense to us, but the computer doesn't think like that. You need to have name equals Dan. And the reason why that is because this could be any Boolean expression. It could be if 6 times 2 equals 12. It could be anything. It could be if, some variable like x to the power of 2 is, or if x to the power of 2. If you remember from last video, that's how you do exponents equals 25. So, I don't know. Oh yeah, it's giving me an error because it doesn't know what x is. But the point is that any of these Boolean expressions can be anything. It doesn't just have to be a single variable. But let's put that back, because that was nice that we had before. Alright. So far, in order to change the name, we have been just editing this variable, which is fine. But, in most programs, in order to type in your name, you don't have to edit the source code. But so far, that's what we've been doing. The way you would do that in Python is you use another function like print. So far, we've only learned one function, print, which just displays text. We're going to use another function like print that works exactly the same way, called input. And what input does is it takes, in sort of this hug that it's giving to these quotes, it takes a message that it wants to display to the user, just like print. Let's say, what is your name? And you put a space at the end. It's just good form so that there's space after. Well, you're going to see what's going to happen. So we have this sort of text, and let's actually just put that name back. Name equals what does it matter? So input, what input is going to do is I'm going to show you. We run. It's going to ask us for our name, and you can type down here. You can say my name is Dave, and it says you're the programming teacher. But this does not look like right, because Dave is not the programming teacher. Well, he was my programming teacher, but he's not yours. But what are we gonna do? Because input is obviously capturing some sort of data. Like we were able to type down there, but where is it going? And this is something that we haven't encountered yet. It's a function, unlike print, that returns a variable, or returns a value. Sorry, not a variable. And because of that, a value is like up here, like Jonah or 5 or something like that. What we can do. This is going to be mind-blowing. You can set name equal to input. So whatever text we type down here, it's going to store in name as a variable, as text. So let's try this out. What is your name? Jonah. You're the program teacher. But that's exactly what it did last time when I typed Dave. So let's try again. Let's pretend we're Pete. You're a programming student. Let's try Dan. Dan, you're a programming student. And finally, let's try Dave. I don't know who you are. It works. We're able to type information into the computer. The computer will understand what we're saying. It will give us a special message based on who we are. Which is just really cool that you can do this. And also, let's say, we want to include Dave as a programming teacher up here. We can say if name or name equals Dave. All right. So now when we type Dave, we'll get programming teacher. All right. So that's about all we have for today. But I hope you enjoyed this lesson. I hope it was useful, as we have sort of learned about Boolean expressions. And capturing user input and creating these sort of blocks of elifs that you can have as many as you want. You can have these if statements. So you can create a program that changes its behavior based on certain values and if they're true or not. So thank you. See you next week.